Great, thank you guys. Thank you for having me, everyone. My name is Glenn Booth. I'm the VP of Marketing for Dimetis. Dimetis is a German company, been around almost 2 decades. We develop media workflow automation and orchestration software tools. So all this stuff over IP is exciting for us. We are very excited. We all know the power of IP, but I wanted to just share something with you. I spent a lot of my years in telecom, specifically voice switching. Some of us remember the old days when you had to make a long distance call to Europe. It was $3 a minute. Well, back then the equipment was this tall proprietary switch made by one manufacturer. It got moved to IP very quickly. It was soft switch, which in essence is virtualization of hardware, where you're taking the functionality of the hardware, moving it to software, and then just running on a powerful server. That's what happened about 15 years ago. Now we're at the 2 cent a minute long distance rate. So that's one of the things you see of IP, just collapses the whole pricing structure and makes a lot of new functionality available. Obviously standards and interoperability is the key here for the SMPTE standard. I keep thinking of a USB drive. I know it's sort of simple, but one of the things we're really doing by all this is removing the complexity from the user, removing manual operations. Let computers do what they're good at doing. So you plug this in, all this crazy stuff happens in the background that you're not even aware of, right? The system says, well, okay, who are you? What kind of device are you? Who's the manufacturer? What's your capacity? Oh, and I have a special driver. I'm going to load my system right now. If it doesn't have the driver, it goes out over the internet, right? Loads that driver. And if it can't find it, then it says, hey, operator, user, you, give me a driver, will you? But all that stuff usually works pretty well. In the old days, okay, you guys remember, you have a hard drive, you have to run some software, then you have to mount the hard drive, and all these utilities just to get data off the hard drive. So I love that about the fact that we have a standard, we have all the standards bodies aligned together. In telecom, we don't have that so much, right? Am I right? Hybrid architectures, we all know that we're not going to get to the promised land. It's not going to be like, today we're SDI, oh, and Monday we're going to be all IP, it's going to be awesome, we're switching over. That's going to be very rare. I mean, is that true? It's not true. No, in greenfield, obviously greenfield applications will be true. If you have the resources, if you have the money, but still there's not a whole lot of equipment and software and applications and tools compared to what's going to be like in a year, right? So we'll spend some time just talking about workflows there, and then some of the new IP-based workflows. There's some really cool stuff happening. A lot of it is being shown on the floor here. And then last one is, this new SMPTE standard really opens up the way for virtualization. I was talking before, you take proprietary hardware and you convert it to all software, and now you run it on commercial off-the-shelf servers, really changes the dynamics quite a bit. Everybody knows this stuff. There's a lot of numbers, a lot of acronyms, am I right? So the beauty of this new 2110 standard is great, that it separates the video and audio and ancillary data streams. That really lends itself well to workflow automation. So now you can just process the metadata if you want to. You don't have to worry about bringing in this huge video file. So obviously, uncompressed video, that's the key here too. Excuse me. IP transport of PCM is just pulse code modulation, is that right? Just the way we digitize analog these days, right? But the fact that it's based on AES-67 is great. I'm a composer, a musician, also an audio engineer. That's my background. So I've been following this standard and the work of Ravanna and Dante and what's the QSEQ LAN as well. So I'm excited to see that. My goal is to play with other musicians live around the world. I'm not quite there yet, right? Because the internet has a lot of latencies. We're going to talk about latencies and stuff too. And then the ancillary data channel is great for things like metadata, like subtitles, captions, and things like that. And there's some really neat workflow automation tools there I'll show you. And then lastly, well, the clock that synchronizes everything that makes it all work, right? So it synchronizes the clocks and systems together. So, and I know you guys, you know this slide too. This is kind of where we're at or where we're just leaving now. The risk is very low for the very short term, right? Stay with SDI, it's going to be great. You want to talk to anything IP, you're going to have to translate it. You're not going to be able to really take advantage of all the IP goodness in that it's not going to be bi-directional. It's just going to be a translation step, right? And then you go to the IP world. All right, this is where it all happens. This is what's going on in the rest of the world right now, right? You have all these new network management tools, the cost, the redundancy, definitely the lowest risk for the long term. And then where we're at now, right? We're in the hybrid. You still need translation, but you don't have to get rid of all your SDI gear. That's the best part of it, I think. Credit to Wes Simpson. Wes here? Wes? No. I borrowed this. I apologize. This is the current hybrid situation. So you have a mix of SDI and some IP as well. And as I was looking at this earlier, I was thinking, this is. Have we ever heard the term glass to glass? Glass camera to glass CRT. Well, I don't think we're using glass anymore, are we? Probably not. Plastic to plastic. But it was all left to right. So the flow you capture, and it ends up in your living room. But if you start thinking about IP, it's bidirectional. I mean, we'll still use the same diagram, but that changes a lot of stuff, right? The data's going everywhere now, and all these systems can interconnect. We don't often talk about that, but I have got a few things to show you here on that. And here you have some shared resources such as storage. And then I wanted to just cover this too. There's a lot of phases. If you make a hardware endpoint device, could be a digital camera. In this case, it happens to be an analog microphone. Then I told you, I already warned you, I'm an audio guy. That's the way I look at the world, right? But this is what we see today. In fact, that's what I'm using right now. I have the mic attached to my ear, right there. And then this device converts it. It's really actually two translations, right? It's an analog to digital, and then encapsulation to get it to IP. But it's one direction, works great, but it's two devices. You now have a cable here. You got two cables and limited functionality. It's just getting the video to the audio mixer, right? And now we're starting to see this, where you take this device and you shrink it down, and chip manufacturers are well aware of this technology. They're just putting it inside the microphone now. So initially the cost is kind of high because it's not a lot of volume, but this should drive the cost way down as the chip manufacturers get on board and incorporate this. So Shure Microphone has already announced, in fact, an IP phone with the Ethernet connection on it. I'm not sure if it's AES-67 compatible or not, but it sure will be. That's not a joke, I swear, sure will be. But it has a port here. Then the final step is a true IP native, as they say. So this is now bidirectional microphone, and you're probably thinking, what does that mean exactly? Do I listen? No. But it has all this extra functionality. Now it's got a computer on board and some software and some intelligence. There's a lot of things you can do here. For instance, feedback control. Now you could do that with this mic if you wanted to as well, even an analog mic. Feedback control or dynamic EQ, automatic gain control, all that stuff could be done on the microphone. But here's the beauty. The server, the master controller, controls all these devices and notices that maybe the microphone fell down and they can shut down the volume, or two other microphones are picking up the same thing, so we're going to mute that one. There's a lot of things you can do that will help the overall recording. So that's down the road. That's going to add more cost. But again, over time, the cost will go way down. So bidirectional is kind of for a microphone, it's a little strange, I understand, but some really cool things. But that's sort of the evolution, as you'll see, the phases. This middle phase is kind of where we're at now, somewhere here. But when they get truly IP native is when all the functionality gets built in. Okay, here's a similar diagram. This is all IP. This is the promised land, right? Everybody's happy, everything's easy, just plug and play. Well, okay, someday that could happen. I wanted just to add a couple devices to this diagram, though. The first one is a lot of storage. Now, this storage, SAN or NAS, SAN is just a network of storage. NAS is just kind of one device. But this could be on-premise, or if you have really good specifications, i.e. latency is low enough, you can have it offsite or on a cloud-based thing. Analytics engine, I've seen a lot of displays of AI and machine learning. People are throwing these terms around a lot, big data, all that stuff. But on-premise, having a server is all that means, right? Analytics engine is just a server. The fun is all in the software. So what is the software doing? It's looking at everything all the time. It's looking at all your video quality specs that we've come to love, but it's also looking at IP specs, right? Oh, hey, you dropped a frame. You dropped a packet, You dropped a packet, an IP packet, not a video packet. You've got this oversaturation. You don't have enough bandwidth here. This guy's being overutilized. This guy's running hot. All these things, just think about, it's just hard to even imagine how much data we can gather on, I'm going to call this a LAN for now, right? And then lastly, cloud-based workflow automation tools. In this case, it's a contribution network provider. So people carrying the traffic for the video producer, These guys now are looking at adding storage as a value add to their services. Like I'll bring your game from Brazil up here, but also we have all the storage. You might as well use it. It's connected to the network, or even analytics engines. Like you see, I just saw the Amazon site exhibit, and they are offering AI services. This is crazy, right? Already. So we'll talk about that a little bit too. And it's worth noting that just because your IP, some people say, well, so you can now jam with people, in Japan. No, you cannot, because the public internet is not deterministic, right? You don't have any idea what the route's going to be, and you certainly don't know what the latency is going to be, but you know it's going to be high. So all this is highly skilled people designing networks, so it's very, very fast. And then if you do go to the cloud, they're usually, I would say, a private cloud, right? I don't know if you've seen this again, but one of the beauties of the SMPTE standard is the interconnectivity between all these domains. It's something we've never had to this level. So you build, you say you have a scheduler that builds a circuit up, you have a live feed, you have the event, and then you bring it down. That could go feed all these systems, your CRM, which is your customer or your client, relationship management, that could go into a record and feed all these other systems. So just the fact that everything's now so interconnected really opens it up for a higher gain in efficiency. You could have your content management system talk directly to your digital rights management system, right? So there's a lot of benefit from doing all this. So what I'd like to do now is just talk about a couple workflow automation tools that are out there that we're seeing. Some we're working on, some we're working on with partners, and some people are just doing some really cool stuff. So here's the coolest one, I think, if you're into sports. This particular analytics application, I think, is actually marketed more towards the teams. So you're a coach, you want this data, but it's kind of the same in a way. So what this is the software sitting back and watching every single frame of data. Because that's what they're good at doing, right? And watching this player and seeing his entire routes over the whole game, and then deducing that, this player here spends too much time not near the sidelines or whatever the analysis would, dictate. In football, and now we've heard of this, that the analytics engine will analyze huddles. You don't need to see the number of the player. You don't need to see the name on the jersey. They can just tell who he is, I don't know, by his width, or who he's next to, or where he usually goes. And now that inputs all this data right into the metadata, right? So the metadata is just getting filled with insane amount of detail. And again, no human beings having to type, the quarterback is left-handed, right? Or whatever happens to be. Now here's the craziest one I heard. So they're going to be watching the frames and will be able to dictate a quarterback throws a ball. Here's the velocity of that particular pass. Here's the arc of it, distance from the ground. Here's the crazy one, revolutions per foot. How many revolutions per foot does that football have? So in 2 years, you say, I'm doing a special story. I need to search on metadata all left-handed quarterbacks in college that throw a spiral faster than 1 revolution per foot. That's crazy. That's a lot of data, but it's minutia that I don't care about, but the coach might care about, or a recruiter might care about, or so it's really interesting. And it does take storage. It's not near what it takes for video, obviously, right? And then the obvious one, speaking of volumes of data, is it's just where do you have your storage? First of all, have you planned? Have you really strategically planned for all this crazy, these new resolutions, new frame rates? What's the metric is about an hour of video of 1080p, I think at 24 frames per second is about 25 gig needed. Now you go up to 4K, 5 times that amount, right? So 4K at 24 FPS is like 125, 130 gig for an hour of video. All right, so this starts going up pretty fast here, right? And then higher resolutions, higher frame rates, just go insane. So how do you do this? And then what are the specs here? Luckily, in our favor for the SMPTE standard, disk drive, hard drive storage just keeps coming down and down and down, and they get more and more rugged. So whether you put it on premise or it's cloud-based, may not be an issue at some point. As I said, the contribution network carriers are doing that. Security encryption, huge factor, right? Is your data safe as always? redundancy failover. You know, these guys, even on-prem stuff, are super secure. They're RAIDs, so if one goes down, they shift over the load to other ones. Rights licensing, that is always an issue. Where is this proprietary information being stored? And then obviously latency kind of drives this whole thing. These little on-premise guys now are higher than a gigabit per second access rates, which is just phenomenal. And that's the same time as the price is dropping. So, you know, it's just like in anything else. You got to spend a premium to get the super high stuff, but over time, it's available to everybody, right? And then, again, back to analytics. There's a new kind of analytics that's forming. We're involved as well, which is analytics of workflows. So let's just take that for instance. So how efficient are your workflows? Where could you improve? Oh, I see that, you know, these two operators are doing this thing a time of day. Maybe there's price considerations. What is your price efficiency of all that stuff? Are they using resource properly? So you set the goals of that's the KPIs. You set your key performance indexes, and the dashboards are designed to be very flexible and programmable, that you can look at that in a heartbeat and you see a lot of red, so you know that you're maybe not using the right resources in your workflows, right? Monetization, resource scheduling, same thing. Connection setup and teardown, that would most likely be externally, right, to a carrier or to a contribution network. And that takes a little bit more effort to be able to hook into those systems. And then lastly, automation and self-healing. We're not talking about external. We're talking about the video production LAN, let's call it. So is the system analytics smart enough, you know, a router smart enough to go, hey, there's a problem, I got failover, all that, but there's a lot of other gear that does not have that necessarily. So can this be a manager of managers in a way and help you with the failover process and auto heal without you even touching it? That's not here today, obviously. That's the goal. And closed loop automation just means that you get a sensor or a problem detected, and then it closes loop by fixing it, just like your car would do, right? Your car is doing that all the time. You just don't know it. You only know it when you hit the alarm that's preset, like, you know, your temperature or whatever, but it's taking care of everything for you, right? While you're driving. So, oh yeah, so this is I think, yeah, this is BBC and Amazon's one of their projects, and this is just a real high level thing, but you know, they're showing, we've got the video, we're going to hand it off to you, Amazon. They take care of everything from the storage to the data transfer, even processing and delivery into a CDN network. So if you haven't seen, it's not a commercial, but there's really some cool stuff going on up there in South Hall. Rugged failover, they got that nailed. The latency, you know, I don't know this is the Elemental Cloud. Yeah, I think it's a private hybrid cloud. But security and rights is still an issue, even though you have failover and you have encryption and stuff. Where is that material? How does it interface? What's the DRM constraints? All that. And then orchestration, I just wanted to give a definition because I've heard so many different versions of what that means. You know, we look at it like, we know we're all comfortable with automation. Orchestration is just a higher point of automation. You're not just automating business processes. You are doing that for sure, but you're also configuring hardware. An orchestrator will configure a software from all different kinds of vendors, right? Third-party vendors. You're looking at policies. It could be legal, could be licensing, rights, it could be all that stuff. And applications as well, and management. So we look at orchestration sort of as a manager of managers, right? You have to be able to hook into all this equipment and software to be able to make sense of it, because there is no one holistic hierarchy to do that. So that's how orchestration came around. And the work that AMWA is doing is great, the NMOS stuff, because it all has to do with figuring out what is in the network, what devices, what's the topology, how are they connected, what is their capacity, right? And can we control the network at all? So it just so happens that orchestration, the center of good orchestration is, you know, a distributed database, and not really data, it's a topology, or it's a dynamic configuration, or dynamic inventory. It's an inventory of all the things that are going on, but it's dynamic. So it knows when there's changes, it knows when there's new configurations. So that's really the only way you can orchestrate effectively, right? And then we talked a little bit about virtualization. As we move to more virtualized hardware, again, you'll be needing the AMWA standards and as well as an orchestrator to help you do that. But here, you could build your workflow completely and have the orchestrator take care of everything for you. Onboarding just kind of means, you're onboarding a service or a function. So it's moving to a pretty cool area, and a lot of this is just made possible by the fact that everything's now IP. It's very easy to talk to any of the pieces of equipment in that network, right? And then the last thing is, I don't know if this is going to come true, this is probably just more my opinion, but as things become easier and more plug and play, then you start seeing applications all from every source possible, including open source, by the way. A lot of people in the open source community are working on stuff right now as we speak, but there may be a marketplace. Now, it's not going to be like on your iPhone. It's not going to be like this. It's just a cute little picture, but there will be a lot of little applications in compression or transcoding or graphics or even in the audio side and mastering that you might just be able to pull in for a project, and download it. And we've seen what happens on the prices for apps on the phone. So it's going to be cool, I think, if this happens. It'll be very economical. Interoperability is the absolute key. Well, security is the key too, but interoperability. So you make an app and you make an app, and you guys need to share data. Well, how do you do that? So there's not really a standard for that. There's a lot of people trying to push a standard, but APIs or your interface, application programming interface on your software, which is you publish this and you make it transparent. Here's how you talk to my program, and then you do the same, right? So now there is interchange, right? That will be mandated, and then security, obviously. I'm still not sure, like on my iPhone, who's got what data that I don't even know. But that's going to be a key issue, I think, right? All right, you guys. Don't hate me, SMPTE. IP is everything. It's going to be IP everything is going to be great someday. It's going to be great on the way there too. It really will. And there's always going to be a hybrid phase, right? The old joke is legacy equipment. That's what I sold you last week, right? There's always going to be equipment that's old or not old, but doesn't comply with where you're moving, always. Workflows will get more efficient, that's for sure, and powerful with the SMT2110 code standard. And again, think about moving the complexity out of the way of the humans so they can do what they're good at doing and let the devices do what they're good at doing. It opens up the free markets, the app market we talked about. Again, with our eye on asset management is the core of that, as well as the licensing, right? And then orchestration, well, AMWA standards are not going to require orchestration. Well, AMWA standards are going to open up for orchestration to be around. Remember, to be the manager of all, manage a lot of managers. Manage software, manage hardware, and not solely, don't think about it as manage it. It could be just configure it. Don't have to manage it, but also give me those dashboards. Give me the data on the whole LAN, right? And last one is hardware virtualization is coming. That's pretty obvious, right? But proprietary is moving to COTS or standard equipment, standard servers. So already you're seeing conferencing systems that used to be proprietary conferencing systems now running on Dell servers, right? So they've converted their hardware functionality to software, and now the price just drops really low. So that's pretty much it. Thank you, guys.